Hey everybody, thank you for showing up today. Show of hands, how many of you are running what you would consider to be a non-trivial workload on AWS? Okay, good. So do you suspect that if you were just able to speed up the network a little bit, that you could get through your workload faster or show your customers a better experience using your product? Okay, if you feel that way, then this talk is for you. My name is Becky Weiss. I'm an engineer on the EC2 networking team. And this talk is about networking on EC2 when you're not messing around. All right, so when we talk about speeding up the network, what are we talking about exactly? Well, you know, many people think of a fast network, and they think of the number of gigabits per second. They think of fat pipes. And we do offer up to 10 gigabits per second full bisection bandwidth between our instances, and I'll get to that. But you know, there are other components here as well. There's low latency for fast turnaround of your request response. And not only low latency, but getting that latency predictably low. And we're going to talk about how you can do all of those. Well, this sounds really great. Are you the kind of workload that needs your network enhanced? So really the question is whether you're network I/O bound. So the various kinds of workloads do have characteristics that should make you start thinking about speeding up the network. Anything, you think of high performance computing, HPC workloads from the science and engineering domain, these will typically spin up lots and lots of nodes in a cluster, and communication between these nodes is key to a performant workload. Large data transfers, anything that's very chatty, a lot of request response. If any of these sound like your workload, you should definitely be thinking network when you're talking about making it perform as well as it possibly can. So then what are we going to talk about today? I'll just tell you right now that this talk is going to be very practical focused, very how-to focused. It's really about getting the network to be faster. And there's a couple concepts that we're going to talk about here that these are the things that you need to know about if you're going to make your network faster. So the first one, something called placement groups. This basically tells us at EC2 when you're running your EC2 instances that you are interested in having bandwidth and latency optimized among these instances. We'll talk about how to do that. We're also going to talk about enhanced networking with SRIOV. This is a feature that we released last year. It's all about getting that packets per second up by driving per packet processing time down. And I'm going to talk about what's so enhanced about enhanced networking, and then how to make sure that you have it turned on when you should. And as a common thread throughout all of this is the virtual private cloud, or VPC. Everything that I'm going to talk about today, enhanced networking, requires you to be running your EC2 instances in a VPC. And for those of you who don't know, a VPC is a secure, logically isolated your unit of the cloud that has a lot of the network configuration that you might do in your own data center, you can do in a VPC, except it's all virtual, so it's often easier and more flexible. But I will bring up these concepts as they become relevant. Just know that everything that we're talking about here are essentially VPC features. Okay, so first thing you need to know about when you're serious about the network is there are various instance types you should be looking at. So as you know, EC2 offers instances all along the price performance spectrum. We're going to talk about instances at the high end of the price performance spectrum, the ones that support enhanced networking. There are 3 different instance families that support enhanced networking with 14 instance types across those families. And each of these, I'm going to quickly go through these families. Each of them is optimized for particular kinds of work. There was actually a deep dive. It was SDD419, deep dive into EC2 instances. If you missed it, it'll be recorded and you can watch it later. And if this kind of piques your curiosity about not only these instance types, but the other ones that we offer that I'm not going to be talking about, I would highly recommend that you go and check out that talk. All right, so the first of our families here that support enhanced networking is the compute optimized. Compute optimized, basically you're doing rocket science on the instances. Lots of complex calculations on our instances. Any kind of like big science or engineering workloads, any kind of distributed analytics. These are, this is our best price compute performance point of all of our EC2 instances. I have some specs up here. Then we have the R3, which are the memory optimized instances. So anything you have that would benefit from a really large memory footprint, you want to be looking at R3s for these. So think high performance databases, distributed in-memory caches, all of these things do better with more memory. So R3 is definitely what you want to be considering for these. And then finally, we have the IO optimized I2 instances. These have our best random I/O performance across all of our instance types. Anything that's hitting the disk hard, these are the instance types to look at. So NoSQL DBs like Mongo or Cassandra. Cluster file systems, well, file system, that means hitting the disk. These are the instance types that you would look at. If you look here, you see that their instance storage is instance storage, a lot 1 or 2 or 4 or 8 large SSDs. Of course, you can use Elastic Block Store and EBS in addition to this, but these instances have some powerful disks. Okay, so enough about instance types. So these are the instance types you need to be thinking about for the rest of this talk. I'm going to quickly go through what placement groups are, and we'll do sort of a how-to for how to use them. All right, now first of all, what a placement group is. So a placement group is a hint to us at EC2 when you're launching the instances. I want the network optimized between these instances, and I'll show you when you can't, when it's a good idea to use placement groups, when it's not a good idea to use placement groups, and how you set this whole thing up. But first, kind of by way of explanation, I have up here a hypothetical VPC that you might create. Now, this is a moderate to expert mode VPC here. And I just wanted to kind of quickly go through the concepts here that are relevant to placement groups. So I have 2 availability zones pictured here, an orange one and a purple one. The orange one is US East 1A, and the purple one is US East 1C. Availability zones, as many of you know, each of our 11 regions is divided into multiple availability zones. Now, availability zones are designed to be physically separate and isolated from one another's failures. And you can see how this would be a very useful tool for building your own high availability services, because you will want to be running instances in different availability zones so that they are isolated from one another's failures. But I have just 2 of the several availability zones in US East 1 pictured here. And now a subnet within your VPC is a logically isolated group, grouped by CIDR range, of network addresses in there. Now you notice I have 3 instances in US East 1A, instance 1, instance 2, instance 3. And in fact, the expert mode thing here is instance 2 is actually in both of those subnets, and that's fine, because I can attach multiple network interfaces to that instance. But yeah, so I have my 2 subnets in US East 1A, and this is your subnets on placement groups. So a placement group, so our availability zones, they're pretty large. Our data centers are large. When you ask us to launch an instance, we find your capacity somewhere in the data center, and we start your instance for you. Now, placement group, now, as many of you know, and probably many of you are here because you're the kind of person who knows that network performance is dependent on a lot of physical factors. So placement groups are kind of one of these areas where the realities of physical networking kind of invade this nice virtual world that we've created for you. So placement groups, if you really cared about bandwidth and latency between instances 1, 2, and 3, you would launch them into a placement group together, And we, at Amazon, when choosing where to place your instances on our physical hosts in our data center, would place them in physical proximity to one another to optimize for these things. Okay, so now I'm going to show you how to use these things. Just by way of setup, I'm showing you a screenshot of my AWS console. Those are the subnets that you saw in the other picture. We're going to launch everything into subnet 1A. That was one of the ones in US East 1. Subnet A, one of the ones that we launched into US East 1A. I could have launched into both of my US East 1A subnets, but just for the sake of simplicity, I'm going to be launching into one subnet. Okay, and then since throughout this talk they're going to be showing a lot of run instances calls, so I'm just going to go through some of the basic parameters just so you're not confused about what we're doing here. This is a run instances call without a placement group. This is a normal vanilla run instances call. You can see I'm using the AWS command line interface. I'm running it on Windows. You can get it from aws.amazon.com. We have versions for all the major operating systems. So this is the AWS command line interface. And I'll go through a couple parameters with you right now. So first there's the AMI, the Amazon Machine Image. This is an identifier of an AMI. Now, I'll just say that the choice of this AMI is significant and deliberate, but I'm not going to explain it yet. I'll explain it later when we talk about enhanced networking. So just trust me, this is an awesome AMI to be using for this. All right, next thing is that the instance type that we're using is going to be a C3, I'm saying a C3 8 extra large here. Remember, that's one of the C3 compute optimized instance types. And again, that choice is significant. This is an enhanced networking instance type. Other parameters here, subnet ID is what you think. Security group ID, also what you think. Security groups are how you authorize ingress and egress traffic to your instances from only the addresses you want and not from the addresses you don't want. And I have an SSH key so that I can SSH into my instances. And I'm asking for 2 instances because what I'm going to do is I'm going to ping between them. I'm going to show you how it looks not in a placement group, and then I'm going to show you how it looks in a placement group. Oh, okay, one thing I should mention, yeah, there's going to be numbers. You're all grown-ups here. Your mileage may vary because, you know, again, it's physical networking is subject to a lot of physical factors, and the important part here is the relative difference. You know, if you went home and tried this, you would see a good relative difference. You might not get the exact same numbers that I did. This is something that I did once, not according to any scientific method at all that anybody would be proud of. All right, so I launched my 2 instances, and I pinged between them, and you can see that my average round trip time, I got 167 microseconds, and that's all right, you know, that's pretty good. All right, can we do better? All right, so using the AWS command line interface, I'm going to create a placement group here. To create a placement group, I need to name it, so I give it a super creative name, networking test placement group. The strategy parameter needs to be set to cluster, so don't worry about that parameter, set it to cluster. And then I can describe it back to me, and it says, there's your placement group, it's available. Here's a screenshot of the AWS console with exactly the same thing. There it is. This is the EC2 console. There it is. It says it's available, so let's use it. So this is the same run instances call that I showed you before, except one new parameter. I'm naming my placement group. So I'm launching 2 instances into this placement group, and what we at EC2 are going to do is, in our data center, your instances are actually going to be physically close to one another in our data center. So what do I see when I ping between them? I see 99 microseconds, and that's a lot better than 167 microseconds. So great. All right, so what do you need to know to use these things back home? Well, the first thing you need to know is that placement groups do not span availability zones. Now, if you think about it, you can kind of reason out why this would be the case. The idea of a placement group, which is getting your instances physically close together to optimize for network performance, is completely antithetical to the idea of availability zones, which are by design physically separate from one another. So, you know, so either one or the other, having cake and eat it. You don't do that. So you don't have your placement groups span availability zones. All right, and placement groups are only for certain instance types. This one you don't need to worry about as much because if you're serious about networking, you're going to be using enhanced networking instance types, and all of those instance types are supported for placement groups, so you don't have to worry about that. The other thing that you need to know about this is that you can't, after the fact, take a running instance that's not in a placement group or that's in some other placement group and move it into a placement group. If you need to do this, your best recourse is to create an AMI off of your running instance, terminate it, and then relaunch it from that AMI into a placement group if you really needed to do that. Okay, so let's talk about a few best practices to maximize your chances of success with placement groups. So the key thing about being successful using placement groups is making sure that we have the capacity to honor your request. And what I mean by that is, if you forget placement groups for a minute and think of, spinning up a bunch of instances in an availability zone, where our availability zones are pretty vast. That capacity can come from anywhere in our availability zones, which will help you, which will help us honor your request and have the capacity for it. Now, placement groups. If you launch a bunch of instances in a placement group, leave them alone, and come back, a week later and try to launch a whole lot more instances in that same placement group, well, now we're kind of constrained as to where we can choose capacity for those instances from. And you can launch instances into a placement group after the fact, but your chances of getting an insufficient capacity error are a bit higher if you do that, because we don't have the entire availability zone to choose from for your instances anymore. So it follows from that if you have a horizontally scalable web service, one that you're always elastically scaling up and scaling down, placement groups might not be what you're looking for these. Similarly, along similar lines, it is possible to launch heterogeneous instance types into a placement group. Nothing's going to stop you. In fact, I'm going to do it later in this talk. But your chances of us being able to honor your request, us being able to have the capacity for your request, they are definitely improved if you use homogeneous instance types, if all of your instances are the same instance types. Okay, that's enough about placement groups. Let's talk about enhanced networking. So, remember how I said that AMI, that Amazon Machine Image that I was using before was great, and just trust me, it's great? Well, I'm going to talk about why it's so great right now. One thing about enhanced networking, if you're running on those instance types I showed you, you might already be using it. And I'm going to tell you how to find out if you are and what to do about it if you're not. But first, let me sort of give you a high-level overview of what the big deal is here. So, a big determinant of latency between your instances is how fast each packet gets processed on the way out of your instance through our physical host and onto the network. Enhanced networking, the name of the game there is bringing down that per packet processing time and bringing it predictably down. So a full discussion of the architecture of single root I/O virtualization, or SRIOV, is outside the scope of this talk, but I do want to give you some kind of mental picture, sort of a mental picture of what's going on here, because that'll really help you grok why things are faster, why your packets are moving faster with enhanced networking than without. So you think about a non-enhanced networking instance. Okay, so this is a very crude diagram of what happens to packets on a normal EC2 instance. So you got your instance, it's purple. Because you're fancy, you have 2 elastic network interfaces attached to it. Actually, most of you have only 1 network interface attached to it, but in a VPC, you can do multiple network interfaces. These are virtual NICs. The operating system on your instance, when it wants to send packets out on the network, it sends them to these virtual NICs. Now, what happens to the packets next? Well, of course, your instance is running on a physical host in our data center. And those packets come off of your instance onto a virtualization layer in software on our physical host. Now, that means that processing the packets takes CPU cycles, and it's efficient, but it is certainly below line rate. Also because it is in software running on CPU cycles, it's subject to the vagaries of OS thread scheduling, which means it's going to be very variable also. And I'm going to show you a picture in a couple slides that really drives that point home. But it goes through this efficient but software virtualization layer and then off of our physical host to wherever you're sending your packets. So contrast this with an SRIOV picture. And again, this is a very crude schematic diagram here, again, just with the intention of giving you a mental image here. So when you're running an enhanced networking instance with SRIOV, basically our network device is divided into a physical function and a virtual function. This virtual function is exposed directly to your instance as a lightweight PCIe function with limited configurability. And in your instance, this looks like something called a virtual function driver. The salient point here is that when your operating system sends traffic out of its ETH0 and ETH1, those packets have a direct line to our physical network device and then go off where they're going. They do not go through this virtualization layer anymore. So that should give you an idea of why things are faster and why there's a lot less variability in how fast your packets get off your device. Now, I want to point out one thing about this picture here, which is that this virtual function driver that's exposed to your instance, this is a specialized driver. In other words, the operating system on your instance, your AMI, needs to know about this. Like, it's not transparent to your instance. Furthermore, EC2 needs to know that you're doing this because this is a very different hookup than what you saw in the prior slide. And so there's kind of two halves to this, and both of the halves sort of need to be playing ball in order to have enhanced networking turned on. There's the half in your instance, and we're going to talk about how you do that, and then there's the EC2 half of the picture, and we're going to talk about how you do that. All right, but before I talk about how to do all of these awesome things that you're going to do, let's look at, this picture really drives home why you care about this. So orange is without enhanced networking. Purple is with enhanced networking. This is the y-axis is logarithmic scale. An engineer on our team did some short interval ping tests between instances. And at Amazon, it's important to us to measure the performance of our services at the outlier percentiles, at the 99%, but not just at the 99th percentile, at the 99.9th percentile, and the 100th percentile. So what we have here is percentiles. TP0, that's the fastest packet on your system, the happiest packet in the world. The TP50, the median packet. 99, 99.9, 100, the slowest packet on your system. And you can see that when you're using enhanced networking, these bounds between your slowest packet and your fastest packet are actually pretty tight. Whereas when you're not using enhanced networking, there's, that outlier slow packet is going to be slow. Okay, is this thing on? It might already be. So if you're running the right instance types, the ones that I showed you before, and you're running one of the newest Amazon AMIs, then you can sleep for the next 10 minutes of this talk, because you don't even need to think about enhanced networking. It's already on for you, and you didn't need to do anything. Now, I recognize that many of you are running older AMIs or custom AMIs, and maybe you're not sure, even though you're maybe running the right instance type, you're not sure whether you have enhanced networking on, or you don't and you want it on. So I'm going to show you what you can do about that. Okay, so remember I said that it takes two to tango with this enhanced networking feature. You need it on both the instance, and you need EC2 to be aware of it. Well, so let's first talk about the instance half of it. So on Linux, you can go and use ETH tool. ETH tool will tell you what driver it's using. On the right-hand side, you'll see that it's using Intel 10 gigabit Ethernet virtual function. That's what that Gesundheit business stands for. And that means that your instance thinks it's running with enhanced networking, and that's good. If you see something about VIF or virtual interface, then it's not yet, but no fears. You can do something about it. Here's the analogous picture on Windows. On Windows, you can see what drivers are being used for your network adapter. I have the device manager up here, and I'm looking under network adapter. If it says Intel 82599 virtual function driver, then you're good to go. If it says anything else, then you're not. Okay, so that's what you do to see if you're running with enhanced networking. Let's say you go onto your instances because you're running a custom AMI or whatnot, and it looks like you're not running with enhanced networking on, but you'd like it on. Well, what are the criteria here? So I already talked about the C3, R3, and I2 instance types that you need to be running. 14 instance types in all. You also for AMIs, as many of you know, we offer 2 types of AMIs, country and western, HVM and PV, para-virtualized. And you have to be using the HVM virtualization type for this. There's minimum required kernel versions and driver versions. I have those up here. And really what we were doing before was, or what we're about to do is getting your driver installed. So I'm going to show you examples both for Amazon Linux and for Windows of instances that don't have enhanced networking on, and we're going to turn it on for them. So I'm going to start with Amazon Linux. I'm going to use an AMI from 2012 from the Stone Ages, before many of you were born, and this is an HVM AMI, so I'm satisfying that checkbox, and I'm going to launch it. I'm going to launch it into C3 instance. Let's make it support enhanced networking. It doesn't out of the box. Let's make it support it. All right, well, so I start my instance and I ask EC2. This is how you ask EC2 whether this instance is supporting enhanced networking. It's an instance attribute. So I do this describe instance attribute, SRIOV net support. It responds to my query, but it doesn't tell me anything about SRIOV. That's its way of telling me that it's off. Okay. So Amazon Linux, this actually is pretty easy. I SSH onto my instance, it's telling me something about updating. I go and do my OS update, and then I reboot my instance, and that's about it. I could get back onto my instance and do a mod info on IXG BEVF. That's the driver you wanted, and I would see that it is now there. Not shown here, other distros of Linux. These are all actually documented on aws.amazon.com. Just look for enabling enhanced networking on Linux, and you'll find the steps for whatever distribution you're interested in. All right, let me just show you the analogous steps on Windows right quick. So on Windows, we're going to do something exactly analogous. We're going to go to Intel. We're going to get the driver. It says it's an exe, but it's actually a zip, so you can copy it to a zip. And then extract the files. And then, there's many ways to add something to your Windows driver store. I'm using plug-and-play utility, PNP util, and adding it to my Windows driver store, and great. My Windows instance is ready to party here. All right, now, as you remember, that was half the picture. That's the picture in your instance. So now we're going to do the EC2 half of the picture. Whether you're using enhanced networking or not is governed by an instance attribute called SRIOV net support. We asked our non-enhanced networking instance about it a while ago, and it didn't say anything. So we're going to turn it on. You can write that attribute, but you can only write it when your instance is stopped. Now, this is the easy case. EBS, Elastic Block Store backed instances, you can stop and restart them. And that's what we're going to do here. Instance store-backed instances are a different story. You cannot stop them. And I'm actually going to talk about what you can do about your instance store-backed instances in a little bit. So I stop my instance in preparation for turning on enhanced networking. Now I turn it on. And so I'm going and writing this attribute. It's a modify instance attribute, SRIOV net support. Simple, in case you're wondering. Is there a complicated SRIOV net support? There is not. You set this value to simple. And something you need to know here, this is a point of no return. This cannot be undone, which means before you go and do this, make sure that the instance half of this is actually in place, that you actually did install this driver. Because if you do this and your instance isn't ready to play ball with enhanced networking, well, it's not going to work with that second picture I showed you, and you're not going to have connectivity to your instance and, well, now you're hosed. So don't be hosed. Okay, and then I'm going to restart my instance. And now if I ask EC2 whether this instance is running with enhanced networking, you see that it's saying SRIOV net support, the value is simple, and it's on. So we're done here. Okay, but that was for EBS-backed instances. What about if you have an instance store-backed instance? Well, there's just an additional step you need to do there. So you do all those steps to update your OS and get the right driver. And then, since you're not going to be able to stop this instance to turn it on, you're going to have to terminate and relaunch. And in order to terminate and relaunch, you're going to need to create an AMI from your running instance. That's outside the scope of this talk, but it's not that bad, and it's in our documentation how you go about doing this. And then you're in the same camp as those of you who have a custom AMI on which you would like to just enable it for enhanced networking. So if you have a custom AMI, like maybe you created it off your instance store-backed instance, or maybe you just have a custom AMI, first take an instance that's running that AMI, do the needful updates that I showed you, verify that they're in place, and then you can create an AMI and register it with EC2, telling EC2 that this AMI of yours supports enhanced networking. And I have the command line interface command here to do that. And thenceforth, all of the instances that you launch against that AMI are going to be running with enhanced networking on. So then you can stop thinking about it after that. Okay. So I just made a lot of great claims about how awesome this thing is and how you go about turning it on. And, I wanted to show you some results. So, of course, what I could have done is I could have brought up a bunch of instances and, run some netperf tests between them, especially like the netperf request response tests. But, I was thinking, I don't know, probably none of you are in the business of offering netperf as a service. This isn't the metric you care about, right? You're using, I don't know, actually we have a lot of customers, probably somebody is running netperf as a service. But what you really care about here, you are using networking as a means to some other end. Like you have some other metric that you care about. How many transactions per second, how many calculations per second, whatever it is that you care about. And I wanted to sort of show you a demo where I'm actually measuring on that output thing and showing it getting better with enhanced networking. I'm going to go into a bit of detail about how I actually set up this test workload. And the reason I'm doing this is that I would highly encourage each of you, when you go home, to devise a test workload that models your real workload in the interesting ways, in the relevant ways, and try something like this. And I'm going to show you how you can run a test workload pretty painlessly. This is one of the places where the AWS cloud really shines. Spinning up a bunch of instances, trying something, and then throwing them all away. So I'm going to show you how to, some tips for sort of measuring, for launching things easily, in the hopes that you can take this home and try it at home and see if enhanced networking helps you get more out of those metrics that you actually care about. Okay, so here's the setup of my demo. So enhanced networking really sings when you're running it, when you're using it for either an end-to-end configuration or an end-to-one configuration. End-to-end configuration, maybe you're spinning up a bunch of nodes and you're sort of communicating among all of them in a mesh. This is an end-to-one configuration. I'm going to run one host running a MongoDB in the middle with a bunch of clients around it wailing on it. And I want to know how many writes can all of these clients wailing on it together can get through. My choice of this workload was actually completely arbitrary. I was mostly optimizing on ease of setup. I'm quite convinced that if you choose whatever it is that matters to you, you would see similar results on that actual output metric that you care about. But this is the one that I chose here. Well, so MongoDB, I looked at my instance types. I want, they're going to do a lot of disk I/O because it's a NoSQL document database. So I'm going to treat myself to an I2 8 extra large here. Now, in point of fact, for this stupid test workload that I've set up, it's probably overkill. But I decided to have some fun over here. Okay, so I'm actually going to show you what this test workload does. Again, it's super stupid. Like, I'm going to have these clients. They're going to be spinning in a tight loop. And each iteration of the loop, they're going to pick a random number from a large random number range. They're going to query they have a connection to the MongoDB. They're going to do a read looking for that key. They either find it or they don't. If they find it, they're going to write it back with some attribute update. And if they don't find it, they're going to insert a value. And again, not a very meaningful workload, but I want to see if I have these clients wailing on my database instance, how many writes are they getting through? And you see the final line here is this add write statistic that I'm going to show you later, because I want to actually count how many of these writes I'm getting through across all of my clients. And each of my clients is running this script. I start with one client, run it for a couple minutes, 5 minutes, 2, 5 minutes, 3, 5 minutes, and all the way up till 20 till I tire of the enterprise. So I'm going to make use of Amazon CloudWatch for my metrics, because again, I really want this test, this test workload is not my product. This is not what helps my customers. I want to do this quickly and painlessly. And so I don't want to spend I don't want to burn a lot of time writing scripts to get onto my instances, collect the metrics, aggregate them, show them to me. I want CloudWatch to do the work for me. Many of you are familiar with the CloudWatch metrics that come with your EC2 instances. 7 CloudWatch metrics that you get by default for free at 5-minute granularity. Various system counters like CPU utilization, disk I/O, network I/O. Well, CloudWatch also lets you write custom metrics, and that is what we're going to do here. So this is a function. Every time I run every one of my iterations through that tight loop, I'm just CloudWatch traffics in aggregate statistics. So I increase my sample count, number of samples in this bunch by one. I increment my sum by the value, minimum and maximum updated exactly the way you think. And then once every minute, I will call put metric data to CloudWatch. This is a custom metric that I have creatively named write time. And I'm using a dimension run ID because I run this a couple times and I want to see the results just for the run that I did. And then I clear out my aggregate statistics and see you in a minute. OK, so that's what it does. I also want to show you how I'm launching the client instances, because again, one of my priorities here is that this test workload be really painless. And exactly what I don't want to do is have to spin up 20 client instances and go either manually or via script, have to interact with each of them and give them credentials and make them start running this script and do all of this stuff. I don't want to waste my time with this. So I'm going to show you a couple features of the run instances call that helps you make this stuff pretty painless. So you probably recognize a lot of these parameters from what we've been doing previous parts of this talk. I'm going to point out the new ones to you. I'm going to ask for CloudWatch detailed monitoring. This is not about that custom metric that we're going to do. This is about the EC2 system counters. I want 1-minute metrics for these. These in the Northern Virginia region, it's $3.50 per instance per month for these to get these turned on at 1-minute granularity. That custom metric in Northern Virginia was 50 cents per metric month. In other words, you might be spending more on toothpaste. So I turn on my CloudWatch monitoring because we'll be looking at those in a minute or two. It's important to me not to have to interact with these instances after they start running. So I'm using this user data file parameter. This is a nifty feature if you don't know about it. Passing it a file, it begins with a shebang. It's in one of the common scripting languages. I'm using Bash. And what happens if you specify that is your instance boots up and starts executing whatever's in that file as root. So I'm going to show you what's in that file. It's nothing that fancy. What it does is it installs a bunch of prerequisites. It goes to S3. That's the AWS command line interface that it's using here. It goes to S3, gets that client test script you were looking at a couple minutes ago from an S3 bucket that I have called networking test, and then go. It starts running this script. And that's all. I didn't have to interact with my instances to make it do that. Now, you might be wondering, well, hey, that's downloading something from S3, but you didn't give your instance any credentials. How do you do that? Well, this is another I'm actually going to award myself a badge of security best practices right on up in here. Not only do I not want to deal with distributing credentials to my instances, but it's also a bad idea for the reasons that you think. So I'm going to launch my instances in something called an IAM role. IAM stands for Identity and Access Management. This is the security best practice. If you need to give your instance permission to do things on behalf of your AWS account, you use the principle of least privilege. You give it an IAM role that has permission to do exactly what you want it to be able to do and no more. And I'm going to show you exactly the content of this thing. And you'll notice here that I don't actually have an SSH key on these instances because I don't need it. I'm not going to be interacting with these instances at all. I'm going to launch them. They're going to run my test. CloudWatch is going to aggregate all the metrics for me, and I'm just going to watch the numbers roll in. So my IAM role, real quick, I have a policy governing CloudWatch because that script's going to be putting metrics up at CloudWatch. And I have a policy governing S3. And for S3, I allow retrieving objects only from my bucket. And for CloudWatch, I allow only calling put metric data. My instance has those permissions and no others. And I didn't have to give it any keys, which just makes my test workload a lot more painless. So I run my test. I just want to show you how I can read back my metrics from CloudWatch. There's not much to this. The metric that I care about is that sample count metric, which incremented by 1 each time I went through my tight loop. CloudWatch has been aggregating these for me, and I want to know across all of my client instances that I was running, what's the sample count each minute. There's a bunch of parameters here that should be fairly explanatory. The namespace for my metric, the metric itself, the run ID that I care about, and a start time and an end time. And I want the sample count statistic. Other statistics available are sum, minimum, maximum, average. These all do what you think. But the one I care about is how many of those write time statistic data points were reported every minute. So you ready for some results? Here's the results. The number of write time sample count statistics, purple is with enhanced networking, orange is without. And you can see as I have just a few client instances, this looks like a pretty linear scale. Network is probably not my problem here. But then as you start getting up into this 6, 7, 8, now you see things start to get crowded. I start adding more client instances doesn't necessarily do me that much better. And you see what this picture is telling me is that because I have enhanced networking on, I'm actually able to get more of these writes through. And this suggests to me that the problem really was how many packets I could get onto and off my database host. Now I'm going to show you the same picture, same picture, told a slightly different way. So this is the EC2 metric. Remember, I turn these on at 1 minute granularity, and I'm launching a new instance every minute. That's why you see a continuous graph, not a discrete graph. This is the 1 minute sum statistic of disk write bytes. In other words, how many bytes was I writing to disk on my database host every minute? Now, I'm showing you this. It looks very similar to the other picture, but I'm showing you this because this is the one I care about, right? Because I'm paying for this fancy instance type that has, it's I/O optimized. So I'm paying for all this great I/O performance, but that's kind of moot if something else is getting in the way of me fully utilizing it. So you can see that this fancy instance with its fancy SSD drives that I'm paying for, I'm making it work harder for me because I get the network out of the way there. And this is kind of the crux of why you should care about this, because enhanced networking is going to help you get the network out of the critical path that keeps you from fully utilizing some resource that you're paying for. So with just a few minutes left, I'm going to quickly just recap what we talked about today. We talked about placement groups. Placement groups, what it is, it's something that you specify when you're running instances, a hint to us about where physically to place your instances to optimize for bandwidth and latency among them. You got to use them in the same availability zone because availability zones are physically separate and placement groups means physically close. Enhanced networking with SRIOV, remember your packets are no longer going through this virtualization layer, and therefore we are getting you a very good packet per second rate. and very consistently good. And I showed you, how you see if you're using it and what to do if you're not, but you would like to. And then finally, just I gave you some tips on how to painlessly model workloads in the AWS cloud, because in my opinion, the AWS cloud really shines here. The agility of being able to easily spin up a test workload. You saw I had almost no fancy machinery there running my test workload, and I was able to show why I was able to do more with the resources that I was paying for, that I cared about, than I was without. And I really do hope that you go home and that you try this. I was trying it with enhanced networking and without, because that's what this talk is about. But I do hope that you try this with different instance types, and make sure that you're getting the most out of these resources that you're paying for, especially those of you with serious workloads using kind of the higher end resources. And yeah, and that's it. Serious networking for serious workloads. Thank you so much for listening.